All right, welcome. This is the second lesson of AP Calculus ABA. Remember, a lot of ABBAs, except we don't sing Mamma Mia here. Okay, the Cartesian plane is next. Now, you do need to know some stuff, and I'm not going to cover it in this section. You should know. Go look it up. Distance formula, midpoint formula, Pythagorean theorem, slope, not sloper formula. That's not an actual formula. I just typed in an R accidentally. So let's go E. Let's move that back. Okay, point slope formula, standard form, conics formulas, how to complete the square. For example, if you're given a really long, complex conic formula, you need to know how to complete the square. And just remember, your conics forms are going to be ridiculously long, like ax squared plus by squared plus cx plus dy minus e equals 0. You know, something that looks like that. You do need to complete the square to figure out what kind of conic it is. Or, hint, you can graph it and then look at it on Desmos. It's crazy, I know, but it works. Okay, now, what we're going to be looking at primarily today is what inverses look like, how to find the inverse, and how to confirm inverses. Confirming, really easy. What the inverses look like, really easy. How to find the inverse, for some reason, students forget every year. So here's a quick reminder. Let's go to the graphing calculator. Alright, now inverse operations are just basically, you guys have probably noticed them as, I guess, opposites if you were trained really young. From a young age, like, oh, here's an opposite. It's an opposite operation, but it is an inverse operation. That's what we use to use more definite language in math. So, like, pretty simple one, y equals x. Okay, the inverse of that would be y equals 1 over x. Oh, sorry, not the inverse of that. It would be y equals negative x. That's not a good sign when your math teacher screws up the first day. Okay, so it's pretty well set up. The inverse just looks like that. Well, in actuality, the inverse of y equals x is actually y equals x. How do I know that? Because in order to find the inverse, okay, let's go back. This is a good teaching point. These are reciprocals, so this is not an inverse. Reciprocals are not inverses. Same thing here. If I did 1 over x, these are not inverses, and I'll explain why in a sec. Okay? Alright. Alright. Y equals x. Okay, so what you do is you solve for x, and then you replace x with y. That's how you do it. So if we solve for x, well, x is alone, so x equals y, and then you just replace the two. So technically I should have graphed x equals y, and as you can see, it's the same graph. Okay? So those are inverses right there. Now, obviously, if I stopped there and didn't talk about it, that would be horrible. Okay, so x to the third. Let's work with that one. All right, now, inverses, when you graph them, they make this pretty picture. Okay, they make this pretty picture that looks like this right here. Okay? So right now, y equals x to the third is an inverse of y equals x to the 1/3, which is the one way I know how to. Let's see. Let's go blue. Looks nicer. Okay, which is the one way I know how to graph a cube root. Okay, all right. So it looks really gorgeous, and this will always make this picture, and this always matches up with this line too, y equals x. So if you had to go split it down the middle. Okay, you would make something that looks like this, just a really amazing picture. So it has this nice, and we call this y equals x axis symmetry. Okay, y equals x line axis symmetry. So inverses, when you graph them, they make this beautiful picture that just works this way. Okay. Alright, so what do the inverses look like? They look like that. How to find the inverse is going to take a little bit more thought process. Okay. Now graphing it, not so hard when you have Desmos. It really makes your job a whole lot easier. You guys are going to have to start using your calculators more and more often. Okay, so like let's say we had y equals negative 2x to the fourth plus 4, and I needed to find the inverse of this. Okay, so what I would do is solve for x. So I'd get y minus 4 equals negative 2 x to the fourth. Okay, and then I would divide both sides by negative 2. So parentheses y minus 4 parentheses divide by negative 2 equals x to the fourth. I'm not done yet, so I'm going to fourth root everything. So fourth root parentheses y minus 4 divided by negative 2 equals x. Okay, and for your last step is just replace the x with the y. So the inverse fourth root of y minus 4 divided by negative 2 equals y. Okay, this is the actual inverse of this one. So these two are inverses of each other. Okay, and what we would do is this connotation, we would probably connotate this as f to the x, and this would be f to the negative first is how it look of x. Okay, so this is the gorgeous thing about it, is it looks nice, it just works out. All right, now in order to confirm, you have to do two things. You have to take f of x and you have to plug in the inverse into it. So you plug in the inverse. Okay, so this is where compositions of functions plays out, and you get x. And if you take the inverse and you do the composition and you plug the composition with the original function and you get x, then you have inverses. So this is the actual rule. So if you take the inverse and plug it into the original function, you get done composing and you get x. And if you take the original function and plug it into the inverse and you get done composing, you get x, then you have inverses. I'm not going to lie, you guys, graph it. These rules were come up with well before graphing was made easy, and honestly, it makes your job a whole lot easier. It saves you a whole lot of work. It helps you see it in a new light if you just do it that way, if you just look at graphs of inverse. But if you'd like to do the rule of where you get x and x, that's totally fine too. But that's the algebraic proper way to do it. All right, guys, you have a wonderful day, and I'll see you next lesson.